learn in mechanics what is the place that in physics, what is the position that mechanics have, right? So under this mechanics, we are going to learn about the motion of objects and the forces cause that motion, why the objects are moving, and what causes that object to move. What is the reason for that? What forces are acting on them in order to move them, right? අපි මොනවාද මේ වස්තුන් චලිත වෙන්නේ ඇයි? ඒක move වෙන්නේ ඇයි? මොන forces දාලා මේක move වෙන්නේ? right? අන්න ඒක explain කරනවා mechanics වලින්. So that is mechanics. Mechanics is the branch of physics which explain or which we study the motion of an object and the reasons for and the causes to their motions and what are the forces acting on them to cause that motion. Right? So basically, or mainly under the mechanics, we study Newtonian mechanics. Newtonian mechanics. So you can divide mechanics into two parts. So when we study the topics under mechanics, these are the two parts. We can divide those topics. So there's a static section, static part, and also the second one is dynamic. Static and dynamics, statics and dynamics, right? All the topics or lessons in mechanics, under mechanics, we can divide into these two parts, static or dynamic. So what is static means? We learn about the object in still, object in equilibrium, right? So as example, if you keep this pen on the table, now it is in still. But there are forces acting on this. So study why the object is at rest. What are the forces acting on them? So we say this object is in equilibrium. And why is it in equilibrium? Right? Equilibrium when a part can be center of gravity, equilibrium. Right? Those things we are going to study. Resolving forces, result on the forces. We are going to study on the static part. The next one is dynamics. Dynamics. So there are kinematics. There's a topic called kinematics, which we study the motion of an object, how it accelerates, what is the velocity, what is the speed, distance, displacement, those sort of things we study in dynamics. In dynamics, we study about the motion of the object. Dynamics they are moving. We study about moving objects. Right? It may be a rotational one, it may be a translational motion. Right? So we study those things under dynamics. So these are the topics you are going to learn. These are the lessons we are going to learn in future under mechanics. First, we start from kinematics. Kinematics, right? So we begin with kinematics, then we go to the laws of motion. Especially Newton's laws of motion. And then we study conservation of linear momentum. Friction. We study about the friction. Then resolving forces. Resultant of forces like they So after that, turning effect of the force, moment of force. Moment of force. Principle of moments, moment of force. You will learn. Then center of gravity. Center of gravity. Then we learn equilibrium. Equilibrium of bodies. Right? Equilibrium particles, equilibrium rigid bodies. Conservation of linear momentum. Conservation of linear momentum. Eight. Work, energy, and power. Right. Work, energy, and power. Angular motion. Angular motion. Under the angular motion, we learn about circular motion and rotational. Rotation. Right? So 10th one, hydrostatics. Hydrostatics. And finally, Seventh one, hydrodynamics or fluid dynamics. Fluid dynamics. So these are the topics we are going to learn under the mechanics, right? See what are some other level always at the friction, cross of motion, you know. But now in this lesson we go deep. Right? We go deep. අපි අතොට ගැඹුරට ගිහලා පොඩ්ඩක් කතා කරනවා. ඔය කතා දේවල් එක ටච් කරගෙන ගියේ. F equals mv කියලා. Mass is 2 kg, acceleration is 10. What is the force? ඔයගේ නේද? එහාට ගිහිල්ලා අපි ටුට්ටක් get එක ගිහිල්ලා කතා කරන්න යනවා. Right? So these are the things you consider. Right? So we start from the mechanics lesson from this kinematics. Before that, you need to write a small description about mechanics lesson. What is this lesson is about? Right? Lesson right. The topic mechanics. Mechanics. You can continue the vectors, right? After the vectors now is over, right? You can continue that group. Right. For the topic mechanics, the second unit now, second unit right here. Mechanics is the branch of physics. Mechanics is the branch of physics that studies the motion of objects and the forces that cause or change that motion. It explains how bodies move, how bodies move, comma, why they move, why they move, and how they interact, how they interact with their surroundings. Right. Next sentence. There are two main branches. There are two main branches of mechanics. Number one, statics, statics. But in front of it, statics deals with statics. Statics deals with objects that are statics deals with objects that are at rest or in equilibrium or in equilibrium. The second one is dynamics. Dynamics. Dynamics deals with objects that are in motion. Right. Next. We are going to learn, or we are going to study. We are going to study following topics under mechanics. Under the mechanics. Right. So you can list down all 11 topics. today we're going to start first topic, kinematics. Right. In kinematics, we study about the linear motion or translation motion of bodies. Translation motion of the bodies. Right. So all the motions in universe, right? All the motions in universe we can observe and divide into three main parts or three main types. Right? So there are three types of motions you can see everywhere in this universe. So what are those three types? Can you name them? There are three types of motion. All the motions are under there. Three categories. Huh? One is yes. Again, three types of motions. Huh? Okay. Spring motion. Three types of motion. Motion. Translation motion. Translator motion. Translational motion. One type of motion. Translation motion is then next the second one. Linear motion is a type of translation. Right? Translation motion. Rotational motion. Rotational motion. Then translational motion, rotational motion. So what are the other motions you can see? Circular motion is under rotational motion. Translation motion, right? Rotational motion, oscillatory motion, oscillatory, vibrating particles. Waves generated oscillatory motions. Motion of a mass attached to a spring. When you give a small displacement mass and release, what happens? It oscillates. So that is oscillatory motion. So those are the three main types of motions: translation, rotation, and oscillation. Right? So if you any motion in space may be a combination of one or two or maybe three of those motions. Combination that can apply and single type of it. Right? So here in kinematics in this lesson, at the beginning of the mechanics, we are going to learn about the translation motion. Translation motion. Right? So what is the difference of translation motion? What is the translation motion means? They got about the translation motion here. They call motion a different way. You know rotational motion again? Mega? Its body rotates about an axis which is passing through internally. Right? So in that case, the body does not move as a whole thing. But in translation motion, body moves as a whole thing. Sampurna body movement. The moment Yeah. So this is translation motion. This translation. This is it is a kind of a rotational motion. Right? So translation motion can also divide into two parts. Right? One is linear motion. Linear or rectilinear. The other one is curvilinear motion. Curvilinear. Translation motion you can move this body along a straight path like this. Right? On straight path again. This is straight path. So this is a linear motion. Right? And also the main question again. So suppose we started from this position and we need to move this object to here. Right? So you can take this body like this. So this is a linear motion. So we have particles, all the particles have displaced, or they have the path of the length of the paths of particles are same. Or either you can use a method like this. So you can move this pen from this position to here like this. So you can bring it like this. This is not linear, but it is translational. This is curvilinear. Right? So there is a difference. Make a linear motion, this is curvilinear. So in this lesson, we are going to study about these motions of mirrors, linear motion. Object moves linearly. It moves as a whole thing in a straight line. On a straight line. It moves on a straight line. Right? Ek line minimum line right? Understood? So make translation motion, linear motions we are going to study linear motion. Not curvilinear. Curvilinear linear motion. Right. So now you know what is the term linear means. Body is moving on a straight line. And what is motion? What does motion means? Motion. How do you explain motion? Are we in motion now? Stationary. How we define motion? The object are moving on this motion. Yeah, change object, change its position with respect to time. Relative to time. If the position of the object is varying with the time, we say that object is moving. It is a motion. Motion is a change of position over time. Now I am at here. Right? Then I move to this place. So my position has changed with the time. That means there is some kind of motion. Right? Now move with the motion. So motion is we define motion as it is a change of position of an object or body over time. It is a motion. Right? So then when we explain the term motion, there's another term is coming, that is position. Position. Right? So what is the position means? Position. Right? How do you explain the position of an object? So in order to explain the position of the object, position means the point where that object is at in space. Right? Position can object in space position can. So in order to explain the position of an object, we need a coordinate axis. Right? So suppose this is time axis. This is time. This is something called position. Right? In order to explain the position of an object, we need a fixed point, a reference point. Right? They have explained the reference point and code. Related to the reference point, you can explain the position. Right? So position of view, I can explain your question. Compare with the fixed point. There must be a fixed point to explain the position or define the position of view. Target question again, point definitely there must be a fixed point, reference point. Right? Reference point relative to my question. Then make classroom your question is here. But reference is classroom, something up to. So I can explain your, I can describe your question relative to this board. You are from 2 meters away from the board. So this is a reference point. Right? But someone outside this classroom, he explains your question. So now your question is different. Now you are not 2 meters away from the occurrent tree. So in order to explain in order to describe the position of an object, you need a reference point. Right? So that reference point is known as, this reference point is known as origin. Origin. Position, time. This is origin. This is a fixed point. Right? Suppose this is the motion of this is the variation of a position of an object with the time. An object object P. Initially, this object is at here, right? So I'm joining the origin and the position of the object by a straight line. This is a vector. This is a vector. Take this as O. This point is O. Origin is O. But magnitude of this vector is R1. This is R1 vector. We say this is pointing vector or position vector at here. Position vector. This is position vector. Right? R1 is a position vector. Now, after a while, and after some time, the P particle P has come to this place or this point. Now the P is here. Now the position vector is this one. Position vector is, so it is R2. Now the position vector has changed. It is R2. I don't get this as serious about this is simple thing. Make a vector. Make position represent vector. So vector whatever O, make a the particle with the OA vector OA. Right? After quite a while, after Y, the object has come to this place. Now it is point P. So now the position vector is R2 of the object. So if we join these 2 points from a straight line, so this AB vector is represent part. Vector AB. Go to the vector knowledge. Vectors or knowledge. These are 2 vectors. Right? You can represent these 2 vectors from a adjacent side of the parallelogram. So we parallelogram we should talk about parallel. Right. So this is main side parallel so this is a diagonal. This is the one diagonal. The shortest diagonal. This is shortest diagonal. So displacement vector R is given by, how this R is given by? Where shortest diagonal again? Addition or subtraction? Subtraction. So this vector AB represented by R2 minus R1. Difference of two vectors. So this is known as displacement vector. We have displacement vector. Displacement vector. Away over the displacement vector. Shortest distance between 2 points. Right? That is the shortest distance between A and B, which is known as displacement vector. What do you mean? Displacement vector. Appearance vector. So what do you mean? Vector. Actually, the displacement. Right? The displacement measure there should be a fixed place, fixed point, that is origin. There are the suppose origin is that corner. Origin. Right? Now I am at here. I'm going to point out a line like that. This is my position vector now. There are the mom head again, but then down. Now my position vector is line joining that corner and myself. So what is my displacement? And me line A join again. Right? Okay. So now what is the difference between displacement and distance? So suppose these the A and B points. What is the difference between displacement and distance? Are these two the meaning of these two words? These two means a similar quantity or different? Displacement and distance. What is the difference between displacement and distance? Yes or no? What is your opinion? The monkey distance can over the distance. Right. So what is distance? Distance is the length of the path you take, right? Length of the path you take to reach to capital B from A without considering direction. Without considering direction, without towards any specific direction, you take this path. The length of this path is the distance between A and B. But if you take a certain direction and travels to B from A, this gives you the shortest distance, shortest length of this path, shortest distance. So this is displacement. Take a directional. When you mention displacement, it is also a directional one. It always directional one. Right? Displacement over direction is displacement. But without any direction, you can go anywhere you like, and after a while you are able to come to B. And then that path you take, the length of this path you take is distance. Right? Because the direction like a coordinate. Distance is a scalar. But displacement should be, it is a vector. Always displacement is direction. If we move on a certain direction always and reach that specific point, so you have displaced. That displaced the length between that length of that path you do is representing displacement. That is a difference. That is the difference between the displacement and distance. Displacement is a vector. Distance is a scalar. Right? So you can take any path to reach B. So this path is also represent distance between A and B. The distance you can take either this path. So another one take this path. This also represents this distance. But there's only one displacement. You can only take one displacement from A to B. Become displacement again. You can take a displacement again. That is the shortest distance or shortest length between A and B. Right? Am I aware, sir? Right? So these are the things you need to. But these are bases. The kinematic is built upon this. So you need to know about this. What is position? What is the motion? What is the position vector? And what is displacement and distance? Those are the fundamental building blocks of kinematics. Right? In some area, then I can show you that. Okay. Next day, I might do the 5 minutes. The topic kinematics. Kinematics. Again. Here. 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 We study. Here we study about the translatory motions of bodies. Right. Some topic is done. That topic can on the lines and on that. What is a motion? Question mark. What is a motion? What is motion here? Definition. Define what is a motion? What is motion? Right, Amrit? Motion. The motion is a change. Motion is a change. Motion is a change in the objects. Change in motion is the change in an object. Motion is the change in an object. Position over time. Motion. Right? Motion is the change in an object. Right? Motion is the change of the position in an object over a. Right? Okay. So all the motions in universe are classified into three main types. First one is translational motion. Second, rotational motion. Third one, oscillatory motion. The subtopic is translational motion. Right under it. This type of motion involves the movement of an object as a whole movement of an object as a whole from a place to another. Translational motion. Translational motion. Translation motion. Also classified into two types. One is linear motion, the second one is curvilinear motion. Linear motion, the second one is curvilinear motion. Right? So we are going to study about linear motion. Right? In this lesson, we only study about linear motions. That is the movement of bodies, the movement of bodies on a straight line. But the next topic is position. 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 The position of a particle refers to its location in the space. The position of the particle refers to its location in the space at a given time. In order to explain or describe the position of a particle, we defined a fixed point. Fixed point of reference. Which is known as the origin. Right. Next sentence. Following figure shows the motion of a particle capital O is the reference point. Capital O is the reference point, and vector R1. Vector notation of vector R1 and vector R2. are the position vectors. Are the position vectors of the particles at point A and B, at points capital A and B, respectively. Right. So now you can know that make a complete or net or make a Google over the only this. Point A, point B. You can use different colors. So now is the real challenge. It's coming up. Measuring instruments are not that hard. It was simple things, right? Simple marathon, but actual challenge is like following weeks. Do lot of work, homework on it, hard working, something like that. Right? Don't miss the classes. That is main thing. Right? Classes is current. Otherwise, next week we are at for knowing projectiles there. Again, motion equations, projectiles, vertical motion under gravity, relative motion. Sorry. Now every day is important. Today I am going to there. Next they continue here. Right. We can do only this one. I'll do it. So that's it for now. No, make it. Right. So that's it for this. And next week again, we start. Sorry, how I wish to finish the theories, the kinematics. Always के बोटा कभी लबर से फिर हम इन्हें कितना कॉमन किया करें यहाँ पे, right? तो पेपर का मतलब देना होगा तो पेपर का ये आता है पेपर देखा वो नेक्स्ट वीक के अभी डिस्कस करो हम এটা ऑनलाइन सेशन निकाल लाने नए दिया है वाला नहीं है अदरवाइज नहीं करेगा